So yesterday we graphed systems of inequalities, and today we need to do a little bit more with that. Yesterday we graphed this line. I don't remember if it was in orange or purple, but we graphed this line which was dashed, and we used the cover-up method since it was in standard form to get our intercepts over here, and we plotted our intercepts, and then we drew in the dashed line. We used a test point to plug in to see which side we should shade on. Do you remember all that? And we use these little arrows here and down there, hopefully you can see that, to show us which direction to shade. Then we graphed this line, which is blue now. This is in slope-intercept form, so we used the b value to find our y-intercept, so it's 0, 3 is our intercept. Graph that point, and then use the slope, 4 over 3, rise over run, to find 2 more points, so we have 3 total. This being a solid line, we drew it in. Then we use a test point again to see that this one also needs to be shaded towards 0, 0. So we have our lines, and then you should have shading probably clear in here. Today, since we're going to try to show the intersection of these, I need to have another line, so we're going to graph x is less than 1. This is a vertical line because it is an x. Anytime you have x, that will be a vertical line. If you have y, that's a horizontal line. So x being less than 1, here's our value of 1. This is going to be a vertical line. Notice it is dashed. And we still need to test it, so let me draw it in here, and then we'll test it. Let's test 0, 0. Is 0 less than 1? That is true. So this one's going to be shaded to the left of it. So now we need to look and see where all 3 sections of our lines come together. And if you'll notice, it needs to be below the blue line, to the left of the pink line, and above the purple line. So right in here, this little triangle. So we will shade that, and hopefully you can get this just a little bit darker than the shading you did yesterday. I apologize, I forgot this line yesterday when we were working this out. So when we now have this graph, we need to look and see, we need to find our intersection points. So if you look at our shaded area, I can tell I have an intersection here, here, and somewhere down here. My dashes kind of got in the way. Do you see that those are all the corners, or this is called vertices? We call them vertices in math. These are the vertices of our shaded region. So what we're going to do now is find these vertices using substitution or elimination. So why I have used colored pencils is so it's easier for me to tell which 2 equations or inequalities, pardon me, inequalities I'm looking at. So I'm going to start with this one right here. It is the blue line and the purple line. So the first intersection point, I need to use the blue line and the purple line. The blue line, and I'm going to change them to equals for this work, the blue line is 4/3 x plus 3. And the purple line is 4x plus y equals -3. Now I need to use substitution or elimination. Since this one is already solved for y, I'm going to use substitution, and I'm going to take this stuff and substitute it in place of that y. Plus, okay, now I'm going to remove this y and put in the stuff that it equals. 4/3 x plus 3, and that's going to give me -3. Now I have combined some like terms here, 4x and 4/3 x. When I add those together, I get 16/3 x, so 16/3 x plus 3 equals -3. I can move this -3 to the other side, and I get 16/3 x equals -6. I now need to divide by 16/3, or remember you can multiply by the reciprocal. And once I do that, I get -9/8. So x equals -9/8. So up on my graph, this intersection point has an x value of -9/8. Is that an ordered pair? Not quite yet, so I need to plug this back in to find my y value. So in order to do that, I'm just going to plug it into this blue one. Y equals 4/3 times -9/8, which I got right here, plus 3. I'm going to use my handy dandy calculator. Plus 3, okay, and that's going to give me a y value of 3/2. So we'll go back up here. My y value here is 3/2. Hopefully that was the nastiest one, because that was pretty gross. So leave them, remember, as improper fractions, but that's how you find the intersection. First you figure out which two lines you're dealing with, and then you use substitution or elimination. So let's do our other two. We'll do this one right here. This is the pink line and the blue line. So over here, hopefully you have enough room. If you don't, grab another piece of paper. So my blue line is y equals 4/3 x plus 3, and my pink line is x equals 1. Now this is really nice because it already told us my x value. So look, I can already go up here and put in a 1 for my x value because it says x equals 1. Then I can plug that in using substitution. Y equals 4/3 times 1 plus 3. So y equals 4/3 plus 3, which is 13/3. So 13/3. Again, remember to leave that as an improper fraction. So we have two of my intersection points. We need one more. This one is the pink line and the purple line. So when I go down here, I'm going to write my equation for the purple line, which is 4x plus y equals -3, and the pink line, which is x equals 1. Again, this is going to be one of those easy ones because they already told us the x value, so we can just put it in there. Now we need to find the y value. So I'm going to take this 1 and put it in for x and then solve. So I've got 4 times 1 plus y equals -3. So 4 plus y equals -3. If I subtract 4 from both sides to get y by itself, I get -7. So my y value is -7. You do have a homework assignment over this. This homework assignment and yesterday's homework assignment are both going to be due on Monday. So make sure that you get those done sometime this weekend. So your first homework assignment is just going to be graphing the inequalities and shading. The second one, you're going to be asked to find the shaded region and find the vertices. These are called vertices of the shaded region. You can always go to the YouTube channel, youtube.com/user/MillerAlgebra2OHS. That's above the screen in orange if you need to watch this video again. Hope you have a good weekend.